So as always, we are waiting for like 5 minutes past the hour to start our session. Hello, Marion. So maybe we can get started. Pascal, want to do the honors?
Hello all. So this is the SCHC interim for July 1st, 2025. This is an official IETF meeting, and as can be expected for IETF meeting, we have to comply with the usual not well. So if you're not aware of the Cisco practices, please review this page carefully and go through the best practices that are listed at the bottom, in particular about patents. If you're aware of any IPR that new IPR is being discussed in this meeting, and that has not been announced, please let us know or refrain from talking about this IPR at all. And with this, the agenda for today is a discussion on erratas, which are listed at the end of this slide, where on RSC 8824. Then we have the use of CoreConf for rule management, and that would be Laurent presenting. Then the rule management for the new TikTok work, that would be Alex, and then Laurent on seed allocation. So the IETF 123 agenda, the final agenda has been published, and we'll be holding our meeting on Wednesday in room Segovia. so Wednesday afternoon. So we have 90 minutes. We hope we'll see you there. Alex, do you want to say something?
Yes, yes. I mean, so it's the side meeting.
Castilla,
So that's the
sorry.
good. Yes, and it's Castilla. Yes, just that. I mean, I imagine people that will be there, they will see the difference, but yeah. And we have the side
Yes,
meeting.
and sorry, Alex, by the way, when I sent the request for sessions during our meeting, I forgot to place the title in this email, so I saw that you sent one also. So yes, we have sent 2 requests for agenda items for the meeting on Wednesday. So please reply by the dates that are indicated, and send the slides also by the dates that are indicated. We have already published a skeleton slide that you can download, so you can use that in PowerPoint to build your own slideware. And yes, Segovia is different. Segovia is the, well, maybe you want to discuss it, Alex.
Yes, yes. I just wanted to say this. So about this side meeting. So I mean, we discussed this in the working group, and we really feel like, first of all, like the authors of the SCHC architecture document, but I think as a whole that it's really important that we have this meeting focused on the SCHC architecture. So it's SCHC architecture design team, but it's really open to everyone. So please come if you are there, and basically the idea is to have like a deep dive in the draft. So this will be the way to work. We'll do a deep dive in the draft, and we'll have a really rich discussion on the definitions. And so a lot of the things that we have in the architecture draft, like the definitions, they are today as they are because like all these things, they have implications, right? And sometimes it's a little bit complex to discuss all these things in details, like in an interim meeting like this. We need to be around the table and really have this time dedicated for this work. So this is really the topic of that meeting, and the goal, of course, of that meeting is that so we feel that the architectural draft right now, we are very, very close to, like, we agree on a lot of the things, but the point is that everyone in the room and also everyone in the working group then is like really confident that we know why the things are the way they are in the draft. So if there are changes to be made, of course we can make them, so nothing written in stone. We feel that it's not much will change, but it's really important that we have this discussion, right? So that will be like on Monday, and then on Wednesday, of course, we'll present if they're like how this meeting went, and of course there is also a way to participate remotely. So that's this for me, Pascal.
Thank you, Alex. So please reply to the request for agenda items soon, so we can build our agenda. And the last date for actually publishing our agenda is actually the date that we gave you as ultimate date for sending us the agenda request. But obviously, we would like you to send them before that date. So document, we're very stable. We still have these discussions on the protocols number. I have pushed again the original author of the protocol numbers, asking if he wants to continue editing. I did not get a response, so maybe I just take over that. The big change based on the early INTIR and TSVR reviews is that we'll stop talking UDP at all, because there is really a strong pushback against doing that. And also, by the way, Eric made a review indicating that some sections were empty, and they were actually the sections dealing with UDP, just because we had nothing at that time. And so there also will be the sections that will go away if we remove UDP completely from this document. And the rest, we've been pretty much stable. Now there is this discussion, Eric, that you want to have about the errata. Eric, are you with us?
Yeah, indeed, and thank you for preparing it. I prepared as well the PDF, but that's better like this. So Marco is online, and basically those two erratas are kind of, I would say, complex, but they are technical, right? So if they are valid, they will be approved and verified, as they say. This one is kind of easy, but I have no time actually to redo the math. So Marco, if you can explain it.
Yes, hi everyone, and thanks, Eric. I'm a bit rusty on the details myself because I filed those at the beginning of the year, but still, I'll do my best. And assuming this is correct and later approved, the text in the latest version of the 8824 update draft is considering the, I believe, corrected format here. But basically, considering the rule descriptor, we are looking at the KID subfield of the OSCAR option that is 6 bytes in length here, if you count the 12 hexadecimal digits. So 6 bytes, meaning 48 bits. And the intent, according to the rule, seems to be to send 4 least significant bits if you count the 4 Ks at the end. And that means, as I understand, that MSB should have in parentheses number 44, meaning 48 minus 4, not plus 4. Meaning if of these 48 bits, the 44 most significant ones match with the TV, then you send the remaining 4 least significant. So I think in the original text, the mistake was adding 4 to 48 instead of subtracting.
I mean, at first sight, this looks like a logical explanation, Marco, but anybody knows better or get more information?
No, in fact, it's a very long time ago we wrote that, so I have no memory of that. So I think we have to look at the size and make the computation, but I think Marco hypothesis is good.
By the way, there should be no more information than what I wrote in the notes of the erratum. So think again about it, looking at the text.
So is there a chance that, Laurent, you can validate that and just confirm on the mailing list?
Yes,
It would be
Thank you very
appreciated.
much.
I will do it.
Thank you.
Thanks.
So this one will be fixed thanks to Laurent, and thank you, Marco, for reporting it.
Sure.
And this is the next one. This one is more complex.
Yeah, this is easier, I think, hopefully. It's, I believe, a mistake I noted in one particular compression example when using OSCOR related to the, information transmitted as part of the residue for the partial IV subfield of the OSCAR option. The compression rule that is used to produce this residue indicated in the field descriptor about the partial IV field length variable. And then because of that, as I understand from 8724, if you include in the residue something compressed that was indicated in the rule as to have variable field length, you have to prepend that information with the SCHC particular encoding of the residue length sent on the wire. And that was missing in the original example. And yeah, I'm suggesting that it should be added back and reflected. And that was, by the way, a mistake that I made myself in yet another example at some early version of the draft that Anna spotted. I think it was for the URI host value.
So it's certainly a great catch, Marco. We thank you so much for this effort that you made. Laurent, do you have a comment on that? I mean, yes, we need this length, right?
No, I have to revive my OSCOR before.
And again, the latest version of the draft in its text is already including this as if it was confirmed and approved for now.
Okay, so for IETF 123, I guess, Laurent, you have a to-do list of telling us the mic if you confirm that those errata are correct or not. Is that okay? Can you do that by IETF time? So you have 2 weeks plus 3 weeks?
You reply okay on the chat. So thank you,
Okay.
Laurent. And thank you, Marco. And thank you, Pascal, for the short time
Thank you
notice.
all.
By the way, it's Alex who prepared the slides, Eric. So I just saw your thank you, but thanks, Alex.
No problem. I just did copy paste of Marco's work, so that was the easy part. And I think it's the least that we can do. As I mean, sometimes it's you, Pascal. Sometimes it's me. It's the least we can do for people that actually do the work. So thank you, Marco, and thank you, Eric, for bringing it. Like for making sure we pay attention.
Okay, and with this, we will have Laurent. Laurent, do you want to push the slides yourself, or do you want
You
me
can.
to push them?
I will do it very well. So if you can.
Okay, there you go.
Okay.
Do you want me to give you the hand up then so you can move
Just one
them?
thing,
Or?
just Pascal, really sorry. Just before giving the word to Laurent, I wanted to make sure that you saw in the chat, because you mentioned that you're going to remove the UDP port number part. But Carles, in an email, the mailing list, last week, he actually has a use case for having a UDP port for a SCHC, right? So just before going ahead and removing it, can you maybe look at what Carlos said and maybe have like a loop on the mailing list to see if that's
Yes,
something to
Carlos,
consider?
what we could do together is to review, in particular, the TSV review of why they don't want us to have a UDP port. But basically, they tended to say that it's a port that we should negotiate, not something that should be hard-coded. So it doesn't mean that there won't be UDP, it just means that the port will not be one of the first 1,000 blah ports in the range. Just it would be something that is being negotiated. That's how I remember it, and the reason why was because of how we use ports which are not negotiated, which are well-known, versus ports which are negotiated. And from the reviewer, we are using the wrong type of port. So we have to review. Carlos, if you could just look at, I can bring back that mail to the mailing list on the top, and then you could look at it. But it seemed reasonable to me. Then again, they are the transport expert, and I'm not. But the reason that they gave seemed really reasonable enough from somebody who's not from their field.
Okay, so just let's continue on the mailing. It's just I wanted to make sure, like, before we go ahead and remove it, to take Carlos' remark in account. So Laurent, sorry for interrupting. Please go ahead.
Okay. Do you hear me well?
Yes, very well.
Okay, perfect. So I will talk about core conf management. So it's something we have done with Anna, Corentin, and Marion. So the goal is to install management between two SCHC endpoints. So to help to manipulate a set of rules. So by definition, an instance is something we share the same set of rules. So here it's a way to change it in atomic way, because we always must have the same set of rules on both sides. So here there is many ways to do it, but this draft focus on the use of core conf, because it's something that looks efficient. Next slide, please. Okay, so what is new and what we introduce? We introduce a new kind of rule. So we have already compression, decompression, fragmentation, reassembly, and no compression. And so we introduce a new kind of rule, which is the management rules. And in fact, they are exactly the same as the compression decompression rules. But these kind of rules can manage the set of rules. The other, of course, are not allowed to access to the set of rules. So why we do that is because we don't want to impose some rule ID for this, but putting rule ID in these categories means that these ones are dedicated to management. And why they are compression decompression is because we are going also to compress the IP UDP co-op header to make something very, very little small. And in fact, since we have our own high-speed space for that, so we propose to allocate two IPv6 value, one for the device and the other for the core, and it's FE80 column 1 and FE80 column 2, and the draft also propose two port numbers to be used. So for the moment, we didn't look at the security part, but we think we can either include OSCORE or DTLS when it's necessary to protect this traffic. Next slide. So CoreConf is something that is very powerful. We are using CoAP. CoAP has a reliable mode with con message and acknowledgement, but that's not enough for SCHC management. And I think Alex will continue to talk about that in the next presentation. In fact, we must guarantee that all the rules are the same on both ways. And there is cases where it may not be the case. For example, here in the left picture, you have B that send a SCHC message using the rule X, and this message is delayed by the network. And suppose that during that time we do a management and we change the content of rule X. So it means that when the rule X will arrive to A, the rule has changed, and so the decompression will not be correct. So we have to avoid that when we do a rule modification. So one proposal is to add a guard period after doing the modification. During that time, the rule is not usable. So in fact, as you start changing it, the rule becomes from a state that is valid to a new state that is candidate. And when the rule is in the candidate state, you cannot use it to compress. And if you receive a packet with this rule ID, then this packet has to be discarded. And after that, when it becomes valid, then it's used as usual. So here it's a problem when we do modify. It's also possible if we do a delete and a create very quickly. So this guard period is very important. But if we don't do modification, for example, if we do creation, we can try to optimize things. For example, here you have an example where the rule AX is created. So we send a message to node B to say create these rules, and the acknowledgement is lost. So for A, the rule remains candidate, but for B, it becomes valid, and B can start to use it. And in that case, if we receive a rule X, then it's a kind of implicit acknowledgement, and we can decide that the rule is valid. So it's one optimization we can have for creation. Next slide. Pascal, you're on queue, or you?
Yes, Alex and myself, and I
Okay.
had placed myself earlier. They removed, but please go ahead, Alex. You are first, and then it's going to be me.
So if you wanna, because some of the things I wrote on the chat on the email, so go ahead you, and I will, because maybe it's something fresh. So go ahead, Pascal, and I'll take over afterwards.
Yes, Laurent, there is a traditional way of deprecating stuff, which is probably to have a pool of rule IDs which are not used yet. And instead of modifying rule 23, you would take the first rule, which is in the oldest rule in the pool, and use that number. Like when you have a pool of tokens or things like that, that's how you do it.
Okay,
and that's
yeah.
a way to create a form of guard time, just by the fact that now the new rule comes with the new rule ID, meaning that if the other party has not yet installed this new rule ID, it will just be, oh, unknown rule, I'm dropping.
So yes,
so I'm just wondering why you did not choose that classical pool method.
I will discuss that after, and I think Alex will also continue on that. So the real question is: do we need to modify, or do we create only? One objection of what
you could deprecate as well, but it's a second stage, right? You deprecate 23 after a while, even if you signal that, so it can be reused after another while.
Yes,
but
the problem is that we don't have fixed size rules. So I don't know how you manage a pool, because from time to time you may need a rule size, which is on the part of the binary tree, and maybe after that you delete it and you create another rules, and the rule ID will be longer.
That's the malloc problem, right? I mean,
so the notion of pool,
you fragment memory malloc. Now you fragment the rule space and you unfragment it.
So the notion of pool is not so easy to manipulate.
Well, it's just like memory for malloc. You allocate blocks of different sizes, and then again there is art for doing this. But
okay, so can we go to the next slide?
Yes. So no. So there's. I also wanted to say something. So Laurent, I really think that we should find another way to do things other than this guard period, right? Because I mean, on the email I put like 2 examples where we end up with invalid states that are different. So that's something we really need to make. Like there needs to be a lot of work around that. And so maybe there are a couple of solutions. One solution could be, I talk about this later on, is to have not be able to modify rules. So that goes in the way that what also Pascal said, like just using new rule IDs. So that's one thing. Another thing, I'll also talk about this a bit later, is to, upon creation, to have the rules that are created to be in one direction only. So A creates, let's see, or modifies rules on B. And it actually, this needs to be carefully thought of, right? It's related somehow to the fact that you cannot modify a rule, right? Because the moment you start, I mean, it needs to be very carefully done, like the synchronization, and to make sure that we don't end up with inconsistent states. So
but I think we can keep bidirectional rules on that. If we don't do that, it's that we have to do twice the management, which is not something that we expect. Guard, maybe. So one point is that in any case, if we don't do modify, if you do delete and create, it means that you need a time before reusing an existing rule, because otherwise you may have this confusion. So
time or some explicit confirm. I mean, there are various ways, but there are so different use cases for SCHC that finding that time can be difficult.
Yeah, but SCHC we have parameters, so it can be on the rule that we put this value, and it depends of the desequencing we have on the rule.
Yeah, that's one way, and it's hard. I mean, times are hard, because it's hard to know. No, if you say the time is long, that you cannot reuse this rule ID for a long time, and maybe you need to.
But
if the time is too short, it might be that one packet is delayed too long. It's very hard.
Yeah, but imagine that. Look at the first scenario. You send a message on rule X. You do a lot of things in your system, and then rule X reappears. And so here you have to avoid confusion in any scenario on anything you do. So it means that if you do something on rule X, for example, delete it, you cannot recreate it before the last desequence packet, out of sequence packet arrives.
But you cannot reuse it before that time. Agree.
Yeah.
Yes, there is. Yeah, okay, we can discuss that offline or maybe during another meeting at IETF. It's better
Yes,
for
I mean, yes, so perfectly agree. But here, I think the important point is that there are like a couple of principles that we could make that could solve some of these issues, right? And if we leave them open, like there could be, as you're right, Laurent, we can have like a timer or something. But if we leave it very open and we say, okay, well, there's a timer that will solve that, maybe like like that could also cause a lot of problems, right? So it's a very interesting point. It's a good starting position, but I think like, okay, let's discuss that further.
Okay, next slide. Okay, so here is some example we put on the draft, so I will not go into details, but it explains all the core conf message we can have. So just for readability, we don't put the seed value for identifier like target value, but we put the value in strings. But in a real representation, it will be a number, which makes it much more compact. But here we wanted to be able to read it easily. So here is a way to manipulate on the rule 6/3 the target, to get the target value, to get the matching operator, and to get the compression decompression action of the IPv6 version. So this is one way, and then we have the answer and the response. Next slide. We have the same thing for iPatch, where we can set some entry. We recommend to use this format, which is to point out the entry in the rule, to put the rule number, which field we want, and which what we want to target, and then we put the parameter we would like to change to have something more compact. This is discussed on the draft, and I don't want to go too much in this detail right now. Next slide. So yeah, this is something very important. Also, we introduce one RPC, and I think we can have more RPCs, and for me, maybe it's the best way to manipulate the rule. So to avoid iPatch and fetch, or at least iPatch, and instead of this, use RPCs, because we will have a bigger control on what we will do on management, because iPatch is not very flexible. So here we have an example where we have a duplicate rule that take a rule ID that already exists in the set of rule, and we say make a copy of this rule into another rule. And then we can add iPatch sequence where we say what we change in the rule. So the advantage of this is that we only need one RTT to do that. And if we wanted to do by duplicate and then iPatch, it takes 2 RTTs. And when we look at SCHC to the moon or SCHC to Mars, maybe it's RTT here will be important. So if we reduce RTT, it will be good. The other thing we may do is, for example, instead of having an iPatch sequence, to imagine something that say, okay, on the field number 3, we do this thing. On the field number 4, we do this thing that we cannot do on CoreConf directly, but we can optimize the manipulation on this RPC. We can have also another RPC that is not mentioned in the document, but will be, for example, to make a hash of the rule or set of rule or hash of the rule to be sure that it's correct. So for me, RPC is something we have to deploy more and investigate more. Next slide. So here is, for example, an example of what we can do on March or anything. So we have a generic rule that compress part of the packet. From that, we create a more specific rule. We send the management. So it's a dash message. It's installed the specific rule on both sides, and when the specific rule is set, we can use it until it's not no more used because, for example, parameters have changed or fields have changed. So we go back to the generic rules, and then we delete the old one and create a new specific one that can be used. So I think Alex will go on something similar for the Mars scenario. Okay, next slide. Yes, so we have error management, which can be something tricky. We have different level of errors. We have errors that are due to core conf. For example, if you don't, you give an index that doesn't exist in a set of rules, if it's not correct, etc. So core conf will directly generate an error. There is other errors that are due to the validation of the young data model. For example, if you have a rule where you have a value sent, so you don't have a target value, and if you change the CDA to not send, then you need a target value. The young data model is defined to react to this, and it will generate an error. But it means that you need to have the young data model on your device, and I don't think it will be the case on very constrained devices, because core conf can be manipulated in very few lines of code, but it's not the case for young. So here we have to decide what we do in that case. Do we say, for example, that the validation can be done on only one size, for example, on the core size, and the device size is not obliged to do it? So it's something we have to discuss. And then there is errors that are not handled by the young data model, but are SCHC errors. For example, if you create a rule ID that breaks the binary tree, then it generates an error at the SCHC. So how we manage this kind of error, for example, with RPC, is something we have to see. Currently, it's very, very vague, and the standard, I think we just have a message that says there is an error. Next slide.
I guess there is a question. No.
Sorry.
Yes. When I look at this, it seems to me that you're trying to define a transactional protocol, something which will work or not work. And that gives me basically two remarks. The first one is when you're doing something like this and there can be an error, there is normally always the option to roll back. So you do something, and in the end, I mean, the rules are not installed correctly for whatever of those reasons or what. And there should be a way to send a message to both devices and say, I don't know what happened, but it's not working. So please roll back to version blah of your rule set. There should be a way to at least roll back to the previous rule set before any of those changes happened. Meaning that when you do a change in the rule set, there should be a number to it. And when you start a new change with a new number, and you can always, at any point of time during that change, roll back to previous number. Everything comes back like it was.
I think it's quite complex. Maybe we can have something simple. It means that we can have the initial set of rules, and then we have the management, and that create new rules. And if we want, we can go back just to the initial. But I don't want to have.
Or any. I mean, I'm just talking of some.
I don't want to
have. Happens, and there needs to be a way to come back to something. That's what I'm saying.
Okay, but it has to be simple. But if we have some,
it has to be simple. I agree. I mean, I'm just comparing to the art of basically transactional protocols. And the second thing that you find in those protocols is the concept of two-phase commit. And two-phase commit is exactly the case of having more than one party in which you want to get a commit done, so like commit this new rule. And the way they do it is they send the messages to both parties, and they don't say, do it in 1 minute. They say, acknowledge and understand it and tell me if you're okay. And so if both parties answer, yes, I can do this thing, now the two-phase commit, there is really the commit message, which is the second phase. Okay, you're both happy with this change. Now we commit the change, and there is this message That it's time to both
Yeah.
sides to say now this new rule is created, or now this old rule is.
Okay, so what we have to see also is that we have the Mars scenario, or we have very small network like an underwater communication, and where entities will be big, will also be quite big. So more entity we have, the more trouble we have. So
Yeah. I mean, all this has to be taken into account, but there are reasons why it's done in two phases, and in particular when you don't exactly know what the errors are. So maybe you could have an exception in some cases where you don't really want, you can put the commit inside the message, the first message, but when you can two-phase commit is security fine.
Yeah, but for me, the scenario where you create a rule, the yellow one, was a good example, and I think it's something we can rely on. If we lose the acknowledgement and we receive something with this rule ID, then it means that it had been accepted.
Actually, I think that what Pascal is saying is goes in a little bit in the way with the Mars scenario, where you can actually do like you just create a rule, maybe you create it only for uplinks, and then it works, and then you enable it for bidirectional communication, right? And with this, we could go into something like this, what Pascal is saying, and we stay generally in the framework, Laurent, that you are putting here. But yeah, I agree that we need to really make sure that it's even if it's a simple solution, that it's not something that could in some cases lead to an inconsistent state.
I agree, but I think with simple solution we can have consistency. Okay, so next slide. I think it's the end. Do you have the next slide? Pascal? Do you have... Okay, so yes, just to say that I lost you. So the work, of course, is in progress. It's some ideas we have already implemented in OpenSHIC and MicroSHIC, and in the draft you have a lot of examples of exchange that can be very useful to understand all the exchanges. Thank you.
Okay, thank you. So I'll take from here because I'm the next presenter. Pascal, can you stop? Okay, I can kick you away. Haha. Shared slides. Okay.
I was doing it, guys. No worries.
Oh,
okay.
yeah.
I was also reviewing the notes and changing the notes on.
Yeah. I know. So yeah. So thank you very much, Laurent, for the presentation. Actually, and thank you for starting the discussion together with other co-authors. Actually, I reviewed your document, and this is where I sent like the different issues that can arise when we don't do these inconsistencies, right? And then the point was to see, okay, if we do rule management, of course, the scenarios in which we apply it matters, right? Can you hear me well? Because I don't have a feedback, and I'm not sure if it's okay.
Yes, we hear you very well.
Okay, thank you very much. And so this is where I try to put myself a little bit in some kind of extreme scenario that shows, okay, what could go wrong and what kind of solutions we could have for that. And so this is a scenario like interplanetary communications, and the things that I will say are applicable to that, but probably they're applicable to other cases. And so, like a super short introduction to interplanetary communications, it's like to start off, and this is the first main objective, is Earth to Moon communications. But then it's like Earth to Mars, Moon to Mars, and like in someday, any asteroid or any spaceship in the galaxy not that far away. All right. And the point here is that these communications they happen over point-to-point links, and they have typically very long RTTs compared to what we have seen. Like the most reasonable one is Earth to Moon, And it's an RTT that's easy to remember. It's a round number, 2.56 seconds. But like up to Mars, it could be sometimes 6 minutes, sometimes 45 minutes. And it can even be more, and maybe 11 hours to Pluto, right? And throughput can vary, so it can be really slow, as what we have seen in LP1s, and even like really like kilobits per second. In some cases, if we have like a very a laser going which is really well aimed, it can be like hundreds of megabits per second. So like it depends, right? It depends a lot. And packet loss can be like pretty good if we're communicating to the moon or even to Mars, and it can be like worse if we're communicating to somewhere else. So just to give this like as a framework, as a topic, and I think that SCHC is quite applicable to these kind of networks. And one thing that's interesting here is the very long RTT. And what is the okay, so I'm in the next slide. So the point here is that, okay, we have point-to-point links with very high RTT. Now, how do we do management over this kind of links, right? So this here, what I'm thinking is that having multiple round trips for rule creation or modification can be time consuming, right? So even with like a kind of a transactional security, which would be really important to have in some cases, like if we have a round trip of 45 minutes and let's say we have a couple of losses on the link, like a rule creation or a rule modification can take hours, maybe many hours, right? And like if you want to protect a short flow of something or some packets, then that protect, I mean compress, sorry, then like it's of no use, right? And if we have errors also, that could be costly to handle. So here one of the things was, how can we include it in the design a system that is robust to losses and that minimize round trips? So one thing that I think could be a very interesting design pattern for our rules is to say that rules are immutable. So we can create or delete, but we cannot modify rules. And this actually goes to what Pascal said with when you have a pool of a rule ID, and when you do modification, actually it changes the rule ID, right? So you can actually do that. Right? So a rule can be created with a given rule ID. And then if you want to do a modification, well, you create a copy of that rule and you choose a different rule ID, right? And then if you want, you can delete the first rule ID. And so you can have a pool like this, and if you're in a point-to-point link, actually only 2 rule IDs are necessary, because you can switch basically. You know that you have sent a new rule, and yeah, so you can do that in a very in an atomic way, right? So that's the first principle. The second principle is that operations are idempotent. So deleting a rule once, if you delete 50 times the same rule, well, it is still the rule is deleted, right? It's not going to give you an error about that. Same goes for creation. So if you try to recreate the exact same rule, it actually doesn't give you an error, right? So these 2 things I think are universal for rules. A third thing, and that's another story, but I also think that could be applicable to a generic setup, is to have something that's called like the rule ID space. And so this is the space of all rule IDs, and you define this rule ID space in 3 parts. Like the names are quite stupid for the moment. So eternal part, endpoint A, and endpoint B part. So a short definition. So the rule ID space. So these are the rule IDs that are used in a SCHC instance between 2 or more SCHC endpoints. Right. So let's say it's if we say that in a SCHC instance the rule IDs are with /16, so 16 bits. Well, we can say that all numbers that are over 16 bits can be seen as this rule ID space. Now we have let's say the eternal rules. So here I have an example. So the eternal rules are rules that cannot be deleted and thus cannot be modified, right? And you cannot create anything in these eternal rules. Basically, these are things that are pre-configured. Then you have endpoint A. So these are the rules that are only managed by endpoint A. and it's empty to begin with. And endpoint B, so this is the space of rules that are only managed by endpoint B. So this way, there is no possibility for endpoint A to mess up the rules of endpoint B and vice versa. So the example here is, let's say, Moon and Earth. So the eternal rules are 0 to 1,000, and then we have endpoint A rules from 10,000 to 29 to almost to 30,000, and endpoint B from 30,000 to 60,000. And A knows at any time, like, because it is A that is the only one creating and deleting rules in its own range. So A knows all that, and B does, and they are in the same instance. So let me just show you the example. Right. So the example, Laurent, let me just, because I see the time going and I want to go over the example, then I'll give you the question. Right. So these are like point-to-point links. They are sent and received in order, like, and so the example is the following. A sends to B, create rule 10,020, like with the things that are necessary, like with the specification of the rule, right? It can be a copy of an existing rule with something, right? But create rule 10,020 with the rule. And then right after, it sends the traffic that is compressed with that rule, 10,020. And then at the end, send a message, delete rule 10,020. Right. So we have like a burst of traffic, if you want, and all that can happen without having any feedback, right? So you can have imagine a 10-minute flow that can be compressed on the fly with that rule, and then the rule is freed. And so if you send a flow like this to Mars, so maybe you send a couple of times create rule 10,020 in the beginning, like 2-3 times, then you send your traffic, and then you send delete rule 2-3 times, and then like it's all flying to Mars, right? So yeah, so that's the first part. Then the second example is you can actually say, hey, there is a lifetime to a rule, right? So on creation, the point A can say, well, create rule 10,020 and lifetime is 4 minutes, right? 4 minutes after the reception, right? And so it can, like, it creates that, it sends that message, it creates that packet, then sends the traffic compressed with it, and after some time, like maybe not 4 minutes, but 3 minutes 30, it starts sending, hey, create rule 10,021, again with lifetime 4 minutes, and so A starts sending traffic compressed with 10,021, and after some time, it will know that rule 10,020 was actually expired, so like it was deleted, so it can again start sending messages, hey, create now rule 10,020, and then like you can send the traffic compressed with the first one. So this way, with 2 rule IDs and when your timers, you can actually have like a constant flow of compressed packets, right? And just let me and there is another point. Actually, we can say that when rules that are in A's range are uplink only, and rules that are in B's range are downlink only. So in this way, like I think that this could be unnecessary if you have you know exactly how much time the packets are flying over the air. So you know that can work pretty well. But actually, if you only say, well, rule A's are uplink only and rule B's are downlink only, then it means that there will be no confusion. Like A knows at every time what's on the other side, and it sends packets, and like the packets that are sent, they know they will be interpreted by B because A orders the way it sends its packets. The same goes with B on the other way around, right? So there are no cases where A and B will get mixed up, and so like A creates a rule on B and B starts using it for compressing rules to A, and then they get mixed up. So just this is an example. So you have the rule ID space. So you have the eternal rules that are in violet, the Earth rules that are in blue, and the Moon rules that are in yellow, right? So in the beginning, okay, well, they all start like the ones that they start empty. Like rule 1 2 3, they are shared and they are on configuration. So the Earth sends, hey, create rule 10,020. Then the Moon can say, well, create a rule 30,020, and they live in their own separate space. And so just to show how things are happening as packets are going, so like the Earth can say, hey, well, create a first packet, so it's flying over the air, like create to 10,020 with lifetimes 5 seconds after reception. Then it starts sending the SCHC packets. And then after some point, it is received by the moon. The moon creates it, and then the moon starts receiving the compressed SCHC packets. And then after 5 seconds, well, it deletes it, right? So all that works really nicely for moon. And I think it will work pretty good also for satellite communications, delayed Earth communications, and others. Right? So yeah, I just wanted to show this one. So Laurent, questions?
Yes, 2 points. I think what you say to separate Earth and Moon rules is just to avoid the case where both of them select the same rule at the same time or
Yes.
So I think it's quite restrict. So what you say here is to divide rules. Maybe it's a waste of space when, for example, you are underwater communication, where you will have very small rule ID. For me, you can do that in a very easy way, since the rule ID are defined in a binary tree. You say that this one starts with this prefix and this one starts with this other prefix. On the minimal, we say, for example, 0 is one side and 1 is the other side, and you solve the problem. So I think it's more flexible than just giving a range. And if you don't give a range, you can, if you have a collision, then you can have a tie break saying, for example, the core is a winner or the device is a winner.
Yeah, I don't think, Laurent, I don't think the tie breaks work when you have a 45 minutes round trip time. Right, you have a collision and like you need to decide.
So you
okay,
define just a prefix and that's enough. But in imposing a size or thing like this is the opposite of what we always say for rule ID. They have no semantic. We don't know the size because it can be applied in different places.
But here I'm not saying that things have a meaning, right? And the binary organization, it's one way of looking at things, right?
No, it's the way of organized.
I think that ranges are like, you can define a range of rules. I mean, that nothing stops her from that.
So, and the other thing is that you say I give a timer when I create a rule, and I don't think it's a good point because you don't know what will be your traffic. For example, you set up the MSB of a sequence field for TCP, and when you traffic, then this value will last few, but if there is few traffic, this value will last longer. So if you decide at the beginning it will be for 4 minutes, and in fact it is 10, then it means that you will have to renew it 3 times instead of having it here, and you delete it when it's over.
So you can delete it at the end, right? The point here is, and this is where I said it's important here for. So first of all, I'm really looking at IPUDP, maybe IPUDP and the outer version of QUIC, right? So you can have
like
a very
TCP.
simple. Sorry?
QUIC is like TCP. You will have sequence numbers.
Okay, I mean it's okay. Then IPUDP if you want. I mean, and then you just see the first packet, and then you see, oh, okay, well, I have a new packet, like a new thing of QUIC. I have never seen that with this IP, this UDP, and this QUIC session, right? So I sent a message, some kind of opportunistically, and saying, hey, create a rule for that, and the lifetime is 1 minute, right? And then after 1 minute, I see that the thing is continuing. So, okay, well, now I'm going to recreate. I'm going to send again, create, but this time it's 5 minutes. And then, okay, then create, and next time is 20 minutes. Like you can have this kind of heuristics where you basically just keep creating the rules. And the point here is that actually it is very I think that it is very costly to handle desynchronizations. Like to live in a world where you are constantly always trying to be like, okay, I create something. Like if you start with the idea that managing rules it's something with zero cost, then you will have a lot of a lot of things to say, okay, we could just do that, right? But handling all these
creating a
handling
rule
all this.
is more expensive than in terms of packet size is more expensive than deleting one.
So the point here is what happens if you lose one of the packets, right? If you lose a delete packet, then
In
your
any case,
other.
if you lose your inu, you are in the same problem.
No, it's not the same, because if you have a creation and then you lose the delete, and so if you have a creation and then you lose the recreate, then you'll have corrupted traffic. So the other side will tell you, hey, I've received some packets with some rule ID that I don't have. So you will know that first you can have something that's saying, okay, well, this traffic was not received, right? So I don't think that should be the right thing to do, but anyway, you could do that, right? But you will know something went wrong.
And delete is not time dependent, because you can delete in background, and creation is real time.
Yeah, but I mean, that's implementation detail, right? So the point is that if you have a delete that is lost, that means that you have a desynchronization between the two endpoints. That means that on the other side, if later on you want to create the same rule, it will be received by the other endpoint, and then they will say, hey, I already have this ID, right? And then of course you will receive it will start. So then what will happen? Like, we need to decide, do you drop the existing, like then you will start receiving traffic. I mean, these are things that could be solved, right? It's not a problem that could not be solved. These are things that could be solved. It's just that we need to write it down, right? So I agree with you that these are things that could be solved, but I think that here we have taking an extreme case like this with this long RTT. It's a good way of thinking of how and if we have losses, of what kind of things we should define on the protocol side, right? Yes, Laurent?
Yes, just to say some positive things. I like the way to send several times the same rule creation instead of waiting for an acknowledgement. So this is a good approach for long RTTs. And so for the moment, we mandate the fact that the con message has to be used for in the draft. Maybe we can say that we can have also a non-message for management.
Okay. Yes. Thank you. But I mean, this needs to go hand in hand with like idempotency of rules, that you don't modify rules, and probably that when you create a rule, when you send a create, you need to be aware of the packet loss over your link. So if it's like a perfect link, well, you can send one create. If it's not a perfect link, probably you'll need to repeat it 3 times or like n times. Like, you send it and then you send the first SCHC packet, and you send it again, and then another SCHC packet, and then again another SCHC packet, until you have some percentage of confidence that it was received, right? Because here is a probabilistic, right? And yeah. Anyway, thank you for that, Laurent. Yeah.
Alex, we already passed the time, so for one thing, we will not have time for Laurent. Second, if you could, yes, you're almost there, right?
When I say just a word, I send the seed file. If someone can double check if I don't miss any value and if it's correct, it's very important.
Okay, we will do that. I'll do that. Thank you, Laurent, for that. So with this, thank you very much, everyone. Yes, Pascal?
No, yeah, I was with you saying goodbye and thank you to all.
Yes, and again, thank you, Marco. Thank you very much for taking the notes. Thank you.
Yes, and we could. I went through some of the comments that were in the chat as well, so they are now part of the general notes. So I hope we're complete now. Okay, thank you all.
Thank you. Bye. See you in Madrid. Yes. Bye.
See you in Madrid.